All right, so let's get started with this session. And before I get on with this session, let us understand one thing about this particular session, that I don't really expect too many questions coming from this particular topic on the paper, because if I look at the last 4 to 5 years of paper, we've hardly seen any question coming from clocks or calendars on that particular paper. Okay. Having said that, please understand this thing, that CAT is always full of surprises, and we are not very certain that this year you will not have a question coming from or clocks and calendars. Okay, so like it or not, when you are going to get into the CAT paper, you will always find a question or two or three questions where they'll put up surprises for you, right? And this can be one of those topics where a surprise can come from, and that is the reason of looking at this particular topic over here in the classroom. Now, also understand that I don't really expect too difficult questions being asked from clocks or calendars for that matter. Okay, so we'll get into both of these. I've kept the sheet not very difficult, kept it very light, so that we just go through the basic concept of this particular topic and finish off some of the questions. Okay, so let's get on and understand. We'll first look at clocks, and then post that we will get into calendar and try and understand how that works. Okay? So let's first start by clocks. So if you look at clocks now, I've always felt this thing that students have come back and asked me, "Sir, can you teach us clocks concept?" But my problem is, when I've taught you circular motion concept, why are we not able to apply that circular motion concept on clocks? It's just that the speed units are a little more different. That's it. There's nothing much. Okay. Nonetheless, we will go on and look at this particular piece. Okay. So let's say if you are looking at a clock, and this is your typical clock that we are referring to, and this is your 12, 3, 6, and 9. And now, of course, needless to tell you, how does this looks like? This has got all of these markings present over here, and that's all. Okay. Now, this clock has got two hands. It has got a minute hand and it has got a hour hand, right? Now, we will first try and understand what is the speed of both the hands. So if I look at a minute hand, this minute hand in 60 minutes would cover how much? In 60 minutes, it would cover 360 degrees, correct? That means in a minute, it will cover how much? In a minute, it is going to cover 6 degrees. So that will be the speed of minute hand, where we say it is 6 degrees per minute as the speed of minute hand. Similarly, if I want to look at the speed of hour hand, if you look at the speed of hour hand in 12 hours, it will complete 360 degrees. That means in 1 hour, the hour hand will cover 30 degrees. Clear? Now, 1 hour is nothing but 60 minutes. So I can comfortably say that in 60 minutes, it's going to cover 30 degrees. That means in a minute, it is going to cover half a degree. So now I have the speed of both hour hand and minute hand available with me, which is 6 degrees per minute and half a degree per minute. Now tell me something, that at 12 o'clock, both the hour hand and minute hand will be together, isn't it? At 12 o'clock, both the hour hand and minute hand will be together. Can you tell me what will be the angle between the hour hand and minute hand at 12:01? What is going to happen? The minute hand would have moved how many degrees? The minute hand would have moved 6 degrees. The hour hand would have moved in the clockwise direction once again by half a degree. I repeat, the minute hand would have moved by how many degrees? 6 degrees. But the hour hand would have only moved in the clockwise direction by half a degree. So can I say that at 12:01, the angle between the two of them should be a 5.5 degree? Absolutely correct. Quite a lot of you have answered me this. This is 5.5 degrees. At 12:02, what is going to happen? At 12:02, once again, the hour hand is going to move by half a degree again for 1 more minute, and the minute hand would have moved again by 6 degrees. That means effectively it would become what? It would become 11 degrees, 11.0 degrees. If you look at 12:03, it is again going to increase by 5.5 degrees, and this is going to become 16.5 degrees. Right? So the angle between the hour hand and minute hand increases at what pace? That is your relative speed between the hour hand and minute hand. What is the relative speed between the hour hand and minute hand? It is 5.5 degrees per minute. That is the angle that is created or reduced. When one angle is created, because it is moving around a circle which has got a 360 degrees, of course, one of the angle is increasing by 5.5 degrees, then the reflex angle is reducing by 5.5 degrees. That is how it works. I hope all of us are clear with this. So the relative speed between the hour hand and minute hand, one of the concept is 5.5 degrees per minute. Okay. Now comes the second concept that we need to talk about, which is at 12 o'clock, both the hour hand and minute hand are together. We now need to understand at what time will the hour hand and minute hand be together once again after 12 o'clock. I repeat my question. After 12 o'clock, at what time will the hour hand and minute hand be together once again? Now understand, initially at 12 o'clock, the angle between the two of these hands, which is the hour hand and the minute hand, is 0, right? At the end of 1 minute, it will be 5.5 degrees. At the end of 2 minutes, it will be 11 degrees. At the end of 3 minutes, it will be 16.5 degrees. Now you should imagine the distance between the two of them increasing in terms of degrees. Okay, so 5.5 degrees, then 11 degrees, then 16.5 degrees. Can you tell me this distance between the two of them should become how much in order for them to meet for the first time? This angle between the two of them should become how much in order for them to meet again? This should become 360 degrees. The angle is increasing at what? Shri, correct? It should become 0 degrees or it should be 360 degrees. Both are the same and the correct things. So if I was referring to the angle between the two of them, which was initially 0, then it became 5.5, then it became 11, then it became 16.5, then what are we looking at? The angle between the two of them should become 360 degrees. So at the rate of what? At the rate of 5.5 degrees per minute. So how much time it is going to take for them to create a distance of 360 degrees, which is 360 divided by a 5.5. 360 divided by a 5.5. So let me solve this further. I'm going to say it is 360 by 55 into 10, then cancel a 2, then make it 11. Then can we say that it is 720 by 11? If you solve it further from 720 by 11, you will realize it is 65 by 11 minutes. This is what this will throw up. So this is the first time when the minute hand and the hour hand will be together. Is that clear till this? At any point, at anything, if you are not, if you're confused about, please do let me know. Quick 30 seconds before we move on. We will now use this particular number, which is 65 by 11, to a great effect to understand all the points where the hour hand and minute hand are together. Any doubts, anyone till this? Please let me know. Quick 30 seconds. None. Okay. Sir, can you please explain that relative speed part? Shri, understand this thing that in 1 minute, the minute hand will move how many degrees? 6 degrees. So on the clock, it will move 6 degrees from 12 o'clock. Suppose this was 12 o'clock and the minute hand would have come over here. But the hour hand would have moved by how many degrees? Only half a degree. Correct? That means what is the angle between the two of them now? This has moved 6 degrees. This has moved only half a degree. This was over here. This has moved only half a degree. So the angle between the two of them that has been created is 5.5 degrees. Clear? So every minute, this is precisely what is going to happen. That minute hand is going to move by 6 degrees. The hour hand is going to only move by half a degree. So the angle created between the two of them will become 5.5 degrees every minute. Is that clear now? Okay. So first time they will be together at 720 by 11. Therefore, second time they'll be together at 2 times of 720 by 11, says Prakash. Prakash, I'll come to that. You are correct with your understanding, but we will try to, in effect, formulate this on the clock itself. Now pay attention. After 60 minutes, what is going to happen? After 60 minutes, the minute hand will come back to 12 o'clock and the hour hand will be at 1. I repeat, the minute hand will come back to what? 12 o'clock, but the hour hand will be at 1. What time? It will be exactly at 1 o'clock, correct? Now, can you tell me from this 1 o'clock, how much more time it will take for them to meet each other. Total time was 65 5 by 11. I'm dividing this 65 5 by 11 and saying after 60 minutes, the minute hand will come back to this and the hour hand will be over here. After the 60 minutes, how much more time it will take for them to meet? Sylvie, Rishika, both of you are absolutely correct. Shri, absolutely correct. It is going to take another 5 by 11 minutes, isn't it? It is going to again take what? 5 by 11. So the first time meeting, the time on the clock should ideally be what? 1, 5 by 11, isn't it? And 5 by 11, if I evaluate this, it is going to become 60 by 11. So can I then say that the first time on the clock when the minute hand and hour hand are together after 12 o'clock is 160 by 11 minutes? That will be the time, right? So that time will be what? More than 60 minutes, right? That means more than 1 hour. That means now they will be together over here, which is at this point, which is at 61 hours 60 by 11 minutes. Is that clear? Any doubts, anyone? Any doubts, anyone? I'll wait for quick 30 seconds before we move on and extrapolate this result to a greater extent. Ajay, this 65 5 by 11 is clear? Just say yes if that is clear. Is this okay that after 60 minutes it will be 1 o'clock on the clock? Just 1 o'clock on the clock after 60 minutes. So from there, will it not take 5 by 11 more minutes? And 5 by 11 is nothing but 60 by 11 minutes. 5 by 11, convert it into this type of a fraction, you will get 60 by 11. So from here, it will move what? 60 by 11 minutes. So 1 hour, 60 by 11 will become the time. Because at 1 o'clock, it will be 1, right? After that, it will take 5 by 11 minutes more. So time on the clock should be 160 by 11 minutes, right? Is that clear now? Okay. Now, I want all of you to pay a very, very close attention so that we can make it a generic rule for us and forget about this forever. Now, understand this thing. This is the minute mark 1. This is the minute mark 2, 3, 4. This is the minute mark 5. This is the minute mark 6. In between this 6, 5 and 6 is the time when they are meeting, correct? That means from this particular minute mark to this particular minute mark where they are meeting, it has traveled 5 by 11 minutes, right? 5 by 11 on the clock. Now, once it has traveled 5 by 11, take this as 12 o'clock. Should it not travel from here again 5 by 11 and meet between 2 and 3 once again? So can I then simply say that the second time meeting should be 2 120 by 11? Does this make sense? Any doubts over here? What am I trying to say? I'm saying between 5 and 6, they met. Between 5 minute mark and 6 minute mark, they've met over here, which is what minute mark? 60 by 11 minute mark. From here, take another 60 by 11 minute mark, and it is going to meet over here. So that is going to be what? 2 times of 60 by 11, which is 120 by 11. Any doubts, anyone? Nikhil, understand this thing, no? From here to here, how much it is? 5 by 11, which is 60 by 11 minutes, right? So again, when they have to meet, it will have to travel 60 by 11 minutes over here, and they'll have to meet somewhere over here. Does this make sense? Again, it is going to take 5 by 11 minutes over here and meet between 3 and 4. Clear? So then between 3 and 4, they'll meet at what? 3 180 by 11. Can you tell me between 9 and 10, where are they going to meet now? Between 1 and 2, they were meeting at 160 by 11. Between 2 and 3, they were meeting at 2 120 by 11. Between 3 and 4, it was 3 180 by 11. Between 9 and 10, what will be the exact time when they're together? What will be the exact time when they'll be together between 9 and 10 o'clock? Kaushik, correct? Karthik, correct? Sylvie, that's not correct. Think again. Between 9 and 10, we are talking about. Divyashri, correct. Prakash, correct. So it should be the ninth multiple of 6 by 60 by 11, right? 9 times of 60 into 9. So it should be 9 hours 540 by 11 minutes. So that's the ninth meeting point, correct? That will be what? That will be the ninth meeting point. Between 10 and 11 also they'll meet. Between 11 and 12, will they ever meet? Between 11 and 12, will they ever meet? No. Why not? Because that will be the 11th meeting time that you are talking about. And 11th meeting time, 60 by 11 will, and take the 11th time of this will give you exact 60-minute mark. So at 12 o'clock, they'll come back again over here, right? So between 11 to 1, there is only one meeting point over here. That means effectively in 12 hours, they'll meet how many times? 11 times. Is that clear? Any doubts, anyone? So this is all what the concept of clock is all about. The moment you understand this and you develop this entire piece that I have communicated for last about 10-15 minutes, the moment you do that on your own once in your lifetime, you will actually never forget this particular concept and you will use it over and over again. And you can use it to your advantage when you are solving the question. Today, when we will be looking at the questions of clocks, you will understand that at some point in time, you can actually use this very, very effectively. Any doubts, anyone? Post this, we'll get into the calendars part of the session. Nikhil, in 24 hours, they'll meet 22 times. In 12 hours, they'll meet 11 times. In 24 hours, they'll meet 22 times. The starting one will not be, either you take the starting one into account or you take the last one into account. You can't take both the ones into the account, right? So you are saying after 12 o'clock, right? So the first, which was originally 12 o'clock, that is not being taken into account. The other 11 points have been taken into account. So in the next 12 hours, again, another 11 points will come up. So that will become 22 times and not 23 times. Clear, everyone? Okay. Now comes the next part of it, where we are going to deal with an understanding of uh, calendars. Now, calendars is something which is once again a concept. Sir, so they meet 11 plus 12, 23 times. No, Gayatri, they meet 22 times. No. In the first 12 hours, they are meeting how many times? In the first 12 hours, they are meeting 11 times. In the next 12 hours also, they'll meet 11 times only. No. So the total will become 22 times and not 23 times. No. You write down the points. The moment you try to explore it on your own on the desk, you will understand what am I talking about. It will be 22 times and not 23 times. Okay. So let's move on and let's try and understand about calendars. Now, calendars is something which is a concept which is a bit more theoretical. But once you understand that concept, it again becomes easy for you. But I do agree to the fact that there are some things that you will have to keep on your mind. And please try and understand what am I talking about on calendars, and it will help you solve a lot of problems. Okay. So the first thing that we need to talk about and understand is the calendar that we are talking about is a Gregorian calendar. And the Gregorian calendar has got one fact, which is 010101 was a Monday. This is a fact that we all need to remember. 010101 was a Monday. Okay. First thing. That means the last day of AD calendar was what? Sunday. The ending day was what? Sunday. And then the next day of the BC calendar then came with was what? 010101. That turns out to be a Monday. That's something that we'll have to remember. That's the first thing. Second thing that we need to talk about is the odd days. Second thing that we need to understand is the concept of odd days. Okay. So last day was Sunday. Then the first day will turn out to be what? Monday. The second day will turn out to be what? Tuesday. Third day will turn out to be what? Wednesday. Then your Thursday, Friday, Saturday, and Sunday. Correct? So this will turn out to be what? 4, 5, 6, 7. The eighth day will be the same as this one. Correct? So eighth day is called as one odd day. Eighth day is called as what? One odd day. Ninth day will be called as what? Two odd days. 10th day will be called as what? Three odd days. Correct? So the moment you calculate the number of odd days, you will be able to understand where is it lying. Clear up to this? So 7 days, you are going to make it as a bunch. All the 7 days will be covered from Monday to Sunday in this. Eighth day will be same as your first day, which will be Monday. And there is a concept of zeroth day that we are using. Zeroth day over here was a Sunday that you are talking about. So you are starting with Sunday, then you are making the bunches of 7 days each. The number of days you make it in 7 days, and after that calculate the number of odd days. This is same as the concept of cyclicity that we have understood when we were dealing with number system. So when you are dividing it by a number and you are calculating the remainder is effectively nothing but the odd days that you are talking about. Yeah. Now keep making a note of all this. When we will solve the questions, you will understand what am I talking about. Till this, at any point in time, if you felt there is something that you want to clarify, please let me know. If you want me to clarify, please let me know. Any doubts, anyone? So a bunch of 7 days, and after that, after all the bunches of 7 days, how many odd days are we getting? That particular calculation is what we are going to look at. Clear? Okay. Now we will look at the concept of a normal year and a leap year. Okay. A normal year has got how many days in it? A normal year has got 365 days in it. A leap year has got 366 days in it, right? Now, if you divide 365 by 7, you will realize it is going to give you what? 52 into 7, which will give you 364. 52 weeks is what we talk about. So it is 52 into 7 plus 1. That is the normal year that you are talking about. Okay. Now, what will be the leap year? Leap year will turn out to be what? 52 into 7 plus 2. So we will always remember this fact that the normal year will have how many odd days? One odd day. A leap year will have how many odd days? Two odd days. Any doubts up to this? Please let me know. Clear? Okay. Now let's delve into this a bit more. Suppose we are talking about a normal year, okay? And I'm talking about the normal year, and the first day of the normal year is Sunday. Odd days basically happening one extra time. Yes, yes, Sylvie, that's correct. On in a leap year, it is happening one extra time. So you can learn it from the fact 52 into 7 will be 364. And if it is leap year, it will have two odd days. And if it is a normal year, it will have one odd day. Is that clear? Does this make sense? Okay. Now, let's say a normal year starts with a Sunday. Okay. Suppose a normal year is starting with a Sunday. What will be 365th day? Can you tell me what will be the last day? Think about it. Think about it again. That is where a concept is missing. That is where a concept is missing. Kaushik, Rishika, Ajay, Prakash. Think a bit more. There's a concept that I spoke about that is missing. Absolutely correct. Muskan, Selvi, Akhil, all of you are correct. Now, please understand this thing. What did I talk to you about? I talked to you about the 0th day as Sunday, right? Now, then one odd day was Monday. So over here, when I'm looking at Sunday, I'm looking at the first day itself, right? So a day before this was what? Saturday. Now your 0th day becomes Saturday, and that one odd day that you are talking about is going to then become what? Sunday, which will come exactly over here. Does this make sense? So a normal year first day and the last day is the same because of the concept of 0th day that we need to understand, guys. I hope those of you had made a mistake of calling this Monday understands what am I talking about. Just give me a quick yes if you have understood. You had made a mistake of calling it as you've not understood. Okay. 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 Let's understand this thing once again. If your first day was Monday, will your seventh day be a Monday? No. Eighth day will be a Monday, right? So what am I saying? The zeroth day, if your first day was Monday, your zeroth day was Sunday, right? Then all the 7 days will be counted in this from Monday onwards all the way to Sunday. So 8 will become what? 8 will give you one odd day. So when you divide 8 by 7, your remainder will be what? 1. So your odd day will be the first odd day, which will be same as your Monday, which was your first day. So if your first day is happening to be Sunday, the zeroth day was what? The zeroth day was Saturday. So your first day is turning out to be Sunday. So your eighth day, which has got one odd day, will be same as your first day. Your next day, which will be 15th day, this will also give you one odd day when you divide it by 7. That will also be a Sunday. So it is important that you understand the zeroth day. Is that clear now? Kaushik, Rishika, does it make sense? So zeroth day is important for you to understand. This is where this concept becomes a bit more confusing. I understand that, and that is why I'm spending a little more time on this. Any doubts? Clear? Okay. So now tell me if it is a, okay, quick 30 seconds, make a note of everything which is there on the screen. Then I remove this and then we talk about a couple of more examples like this so that we understand the concept better before we move on. Any doubts till this? Anyone? Clear? Okay. Now tell me something. If it is a leap year and your first day is Monday, what will be your last? What will be your last day? Absolutely correct. All of you have given me the correct answer. That means my zeroth day will be what? Sunday. Correct? Now I'm looking at a bunch of 7 days and I know that a leap year is 52 into 7 plus 2 more days. Correct? So the last day will be a plus 1 and a plus 2 that you are talking about. So plus 1 was a Monday and a plus 2 will be a Tuesday. So now understand this thing. A normal year will start and end at the same day. A leap year will start on, let's say, Monday, then it will end on the next day, which is Tuesday. Is that clear? Any doubts up to this? Anyone? Okay. Then comes another important point that we need to understand and remember. Okay. So if you don't remember that, then your calculations are going to become way too huge when you are sitting in the paper. Okay. So be very, very clear that you will have to remember this when you are getting into the paper. Okay. Now watch this very carefully. If I go from the first year to the 100th year completion, let us calculate the odd days. How many odd days? Now, before even we do that, we need to understand the concept of leap year and understand how do you understand whether a given year is a leap year or not. When it is a non-century year, when it is a non-century year, divisibility of 4 divisible by 4 gives you a leap year. When it is a century year, when it is a century year, it should be divisible by, it should be divisible by 400. That is when you call it as a leap year, otherwise not. So can you tell me the 100th year, will it be a leap year or a normal year? Will the 100th year be a normal year or a leap year? Instead of calling it as a normal year, non-leap year is what I should call it. So non-leap year it should be. Clear? But If I look at 1600, will it be a leap year or will it be a non-leap year? 1600 will be a leap year, but 100 will not be a leap year. Clear? Now, year number 1 to year number 100, we are now trying to calculate the number of odd days. So can you tell me from the year number 1 to year number 100, how many leap years were there? How many leap years were there from the year number 1 to year number 100? There were 24 leap years. Absolutely correct. How many of them were non-leap year? How many of them were non-leap year? There will be 76 non-leap year because total 100 years is what you're talking about. A leap year has got how many number of odd days? 2 odd days. So 24 leap years will create how many odd days? 48 odd days. Clear? Now, 48 odd days put together will have how many effective odd days? 48 by 7, remainder will be what? 6. So, these 24 leap years put together will give me 6 odd days. What about the non-leap year? 76 non-leap years are there. They'll create 76 odd days. How many odd days effectively? 76 divided by 7. Remainder will be what? 6. So total once again 6 odd days. So if I look at the year number 1 to year number 100, total how many odd days? 12 odd days. Can you tell me effectively how many odd days in the year number 1 to 100? Year number 1 to 100, effectively how many odd days? Effectively 5 odd days. Absolutely correct. Clear? Now, year number 101 to 200 will also have 5 odd days similarly, because 101 to 200 will also behave the same way as 1 to 100. You will have 24 leap years and you will have 76 non-leap years. Clear? Now, 201 to 300 will also give me 5 odd days. Now, 301 to 400 will change. Why? Because 400th year will then turn out to be a leap year. Now, that changed the construct of this 100 years. This 100 years from 301 to 400 will have how many leap years? 301 to 400 will have how many leap years? It will have 25 leap years. How many non-leap years will be there in this? 75 non-leap years. Leap years will create odd number of days as 50, which effectively means one odd day over here. And what about 75? 75 will create 75 odd days, which effectively means 5 odd days. Effectively, it should have been one extra day anyways, because there was one extra leap year over there. So that would have created one extra day. The interesting thing that I want you to understand is, if I look at the year number 1 all the way to year number 400, how many odd days are there? Look at this: 5, 5, 10, 15, and 6. Total 21 odd days. That means what? 21 odd days implies what? Effectively 0 odd days. Does that make sense? Any doubts, anyone? Okay, now understand this thing. And I want all of you to be very careful and answer this. 01, 01, 01 was what? Was a Monday, correct? Can you tell me what will be the last day of this 400th year? Be very careful when you are answering this. I want to see how many of you are concentrating. Turns out all of you are concentrating well. Great, good going. That will be Sunday. That will be a Sunday. So that means in a bunch of 400 years, you will find 0 odd days. That means if I now want you to calculate a particular date, what will be the day on that? You can very easily calculate that, provided you you understand that in 400 years you will have 0 odd days, and in 100 years, other than 301 to 400, you will have 5 odd days. Clear with this? So let's now understand month wise also, to understand how many odd days do I calculate for each of the month. You don't really have to remember that, you can sit in the paper and can do it, but once and for all I will do it on the screen for you, and then we'll move on to the questions and understand how it works. Any doubts, anyone, till this? Anybody? Any doubts? Muskan, the relevance is something that you will understand once I get into the questions. Okay. So the moment I get into the questions, you will understand what am I talking about. After that, also, if you are confused, then let me know. Is that clear? Okay. Let's now look at every month. How many odd days are we looking at? And once we look at that, we will be able to, we'll take a couple of problems. We'll try to understand how to go through that, and then we'll move on. Okay. So if I look at January, this has got how many days total? 31 days. February can have a 28 or a 29 days. March will have how many days? 31. April will have how many days? 30. May will have how many days? 31. June will have how many days? 30. Now July has got 31 days, and August has also got 31 days. Be careful sitting in the paper. I don't want you to mess this up, and just because of a simple concentration lag. Okay. August has got 31 days, and July has also got 31 days. September has got 30 days. October has got 31 days. November has got 30 days, and December has got 31 days. Now, can you tell me the number of odd days that January month has got? January month has got how many odd days? It has got 3 odd days. Absolutely correct. 31 divided by 7, it will give you 3 odd days. February, depending upon the year that you are looking at, will have either 0 or 1 odd days. What about March? Will have 3. April will have 2. May will have 3 odd days. June will have 2. July will again have 3. August will again have 3. September will have 2. October will have 3. And November will have 2. And December will have 3. I hope this is absolutely clear. All of us can work through this and can understand. I'm just doing nothing but dividing this number by 7 to try and understand how many odd days am I getting for a particular month. Is that clear? Any doubts, anyone on this? Depending upon our calculation of odd days, any given date, I can try and figure out what will be the day on that particular date. Any doubts, anyone? Clear? Okay. Now, let's say suppose we try to calculate a date. Okay. Let's say you have 22nd of January 2021. What is the day on this? Try it out. Take your time and tell me the day on 22nd of January 2021. Take a minute's time. Try this out. Sylvie, the question is 22nd January 2021. Which day it is? 22nd of January 2021. Which day it is? I've kept it easy for all of you. All three of you have given me the answer. All three of you have given me the correct answers. Akhil, that's not correct. Nikhil, that's not correct. Okay, let me help you out. We understood that from the first year till the 400th year, there were how many odd days? There were zero odd days. Then we understood 1 to 800 will also have zero odd days. Can I then say the first year to 1200 years will also have zero odd days? Everyone, please stop your solutions and listen to me. Some of you have given me the incorrect answers. I'm explaining it. So, can I then say 1 to 2020? Sorry, 1 to 2000 will have zero odd days. Is that clear? 1 to 2000, year number 1 to year number 2000, we will have zero odd days. Is that clear? Any doubts? Okay. Now, 2001 to 2020 is what I'm trying to calculate. 2001 to 2020. Can you tell me how many leap years are there in this 2001 to 2020? How many leap years? How many leap years? All of you should answer this. There are 5 leap years, correct? How many non-leap years? How many non-leap years? You'll have 15 non-leap years. 15 non-leap years will give me 15 odd days, and 5 leap years will give me 10 odd days. Does this make sense? So total will become what? 25 odd days. Total will become what? 25 odd days. 25 odd days will imply what? 4 odd days. I think I've called a wrong answer as correct answer and the correct answer as wrong answer. Please be careful and listen to me, guys, on this. 4 odd days. We have got how many odd days? 4 odd days over here. Clear? Till what? Till 2020 December end. 31st December 2020, we've got total of 4 odd days. Then what happens? January has got how many odd days? January, and I'm looking at 22 as January, 22nd January. This will give me what? 22 divided by 7 will give me a remainder of what? 1. So there will be one more odd day till 22nd of January. So total 5 odd days is what we are looking at. Clear? Now when we are looking at 5 odd days, your first odd day will be a Monday. Then the second odd day will be Tuesday, Wednesday, Thursday, and Friday should be the correct answer to my mind at the moment. So wait, how 1 in January? Sylvie, which date are we referring to in January? 22nd, right? 22 days. That means 22 divided by 7 will give you a remainder of what? 1. So there is only one odd day that I'm going to count. I'm not going to count the entire January as 3 odd days. Does this make sense? I hope all of us are clear. So it will be the 5th day that we are looking at, and Friday. I think only one of you gave me the correct answer for Friday, which was given by Kaushik. The others gave me a wrong answer and I called it as a right answer because in my mind I had tried to calculate and I probably had gone wrong with that. Any doubts on this? Anything that you are confused about? I'll give you one more example. We have similar questions on the exercise sheet as well. Any doubts? None. Okay, let's take one more example. Suppose I take 17th of Feb 2023. Try to calculate the day on this. 17th Feb 2023. Take your time. I've got three different answers: Saturday, Friday, Wednesday, Thursday. I've got Tuesday. I've got almost all the days. Got very interesting answers. Okay. I think this is still confusing for most of us. From the year number one to the year number 2000, there will be zero odd days. Just calculate along with me the odd days. 2021 to 2022 end, right? This is what we are looking at. 23 we will separately do it. 2020, sorry, 2001 to 2022. 2001 to 2022. How many leap years will be there? Can you quickly comment? And please keep checking your answers. Where did you go wrong, if at all you have gone wrong? How many leap years? 5 leap years. How many non-leap years? How many non-leap years? 17 non-leap years. Somebody had given me 18 non-leap years. Be very careful. Leap years will give you how many odd days? 10 odd days. 17 non-leap year will give me 17 odd days. So total number of odd days will become 27. 27 odd days divided by 7 will give you how many odd days? Remainder as 6. So can I then say till 2022, total of 6 odd days are there? Any doubts, anyone up to this? Then January 2023, I'm talking about, will have how many odd days? January 2023 will have how many odd days? 3 odd days. Clear? Now, February 23, I will not take complete Feb 23 into account. I will have to take only 17 days, and 17 divided by 7, remainder will be how much? Remainder will be 3. So this will give me 3 more odd days. So total, how many odd days are we looking at? 12 odd days. 12 odd days gives me what? 5 odd days effectively. If it gives me 5 odd days, the first odd day is Monday. Second will be Tuesday. Third will be Wednesday. Fourth will be Thursday. And fifth will be Friday. I hope all of us are now clear and you can look at your solutions and can understand where did you make a mistake. Any doubts, anyone? Any doubts, anyone? It's just a matter of calculating odd days correctly. That's all. The moment we do that, we are fine. Clear? Okay. So let me remove this. Let's now move on to the exercise sheet questions. There also some of the repetitive questions are there. Some of the questions are very easy. Some of the questions are made slightly more tricky. Try the first one. Give me the days for both of this. Take your time. Kaushik, Jagrat, the answers are incorrect. Nikhil, the answer is incorrect. Okay, let's try and have a look at the first one. I will still give you time to do the second one. Rishiram, your second answer is incorrect, I believe. Just check that once again. Okay, 21st of January 2024. Let's try and calculate this. Now, we realize that the year number 1 to year number 2000 will have 0 odd days. Will have 0 odd days. Now, 2001 to 2023 will have how many leap years? Leap years will be 5 leap years, and non-leap years will be how many? Non-leap years will be 18. So non-leap years will give me 18 odd days. 5 leap years will give me 10 odd days. Both put together will give me 28 0 odd days. Clear? So till 2023 December, we will have December 31st as 0 odd days. Now you have got what? 21st of January. In January 24 also, you are taking 21 days. 21 days will give you how many odd days? 0 odd days. 0 odd day implies what? 0 odd day implies it is a Sunday. So the first answer should be a Sunday. Please take 30 seconds and let me know if you have a doubt. Preeta, the answer is incorrect. I've solved the answer in front of you, but I don't know you were solving your own answer. Any doubts, anyone? Okay. Let's now look at 30th March 1705. I'll give you 30 more seconds to try this out. Take your time. Shivam, the answer is incorrect. Sylvie, the answer is still incorrect. Check again. Rajni, the answer is correct. Rishika, incorrect. Okay. Quite a few answers have come in. Let me solve this once again then. Understand now what we are looking at is 30th March 1705 and trying to get the day on the 30th March 1705. Understand that year number 1 to year number 1600 there will be 0 odd days. Clear? Now 1601 to 1700, how many odd days? We have already calculated this, so I will not go on to calculate this once again. All of you should remember this. There were 5 odd days that we were talking about. So till 1700 both put together you will have 5 odd days. Now 1701 to 1704 you will have how many years? You will have 3 normal years or non-leap years and 1 leap year. 1 leap year will give me 2 odd days and 3 normal years will give me 3 odd days. Total of 5 odd days till 1704 end, which is December 31st, 1704. Total will become what? 10 odd days. From here 5 and from here 5, you will have 10 odd days. So I'm writing 10 odd days and now getting into the year 1705 and I'm looking at January. January has got 31 days. That means it will give me 3 odd days. February will give me what? This February is of 1705. So how many days it will have? It will have 28 days. So it will give me 0 odd day, right? Now you are looking at 30th of March. In March also you are not looking at 31 days. You are only looking at 30 days. If you are looking at 30 days and dividing it by 7, the remainder will be what? Just 2. So it will give me 2 odd days. Total how many odd days? Total 15 odd days. This implies what? 1 odd day, and 1 odd day will be a Monday. I hope you all are clear. Any doubts, anyone? Look at the calculation, look at your own calculation, understand where you went wrong. Still be careful. Any further doubts, anyone? Clear? Okay. Try question number 2 now. Take your time. Okay, let's have a look at this. My answer is not even in the options. Fair. Let's have a look at this. 2nd March 2013 is a Wednesday. This becomes your 0th day. This becomes what? Your 0th day, right? From the day number 3 onwards, all the way up to March 2013, if I look at it, how many more days are left? March has got a total of 31 days, and this is your 0th day. So after the 0th day, how many days are left with you? You are left with 29 days, and 29 days will give you how many odd days? One odd day now. Okay. So now you are looking at April. April will have how many odd days? April will be of 30 days, and number of odd days will be 2. May will be what? 31. Again, 3 odd days. June will be what? 30. 2 odd days. July will be what? 31. 3 odd days. Okay. August will again have 31. 3 odd days. September will again have 30 days and 2 odd days. I'm not looking at October at the moment, or let's finish October also. This has got 17 days that you are looking at, which will have how many odd days? 3 odd days. Now look at the number of odd days: 1, 2, 3, 6, 7, 8, 9, 10, 11, 14, 15, 16, 17, 18, and 19 odd days. If it has got 19 odd days, effectively you have how many odd days? You have 4 odd days. Your 0th day was a Wednesday. Your 0th day was a Wednesday. So the first odd day will be what? Thursday, Friday, Saturday. And the fourth odd day should be a Sunday. Am I going wrong somewhere? This will have 5 odd days. Sorry. This will have 5 odd days. Fifth odd day will be a Monday. Clear with this? I hope all of us are clear. Please do not make that mistake. I hope there was nobody who wrote 30 for August over here. Is there anybody who wrote 30 for August over here? Just say yes. You can say it on the direct message. I just want to see, are the students making that kind of a mistake or not? You can drop me a direct message if you don't want to claim it publicly. I retraced it to 1st January and counted again. Okay. Stay as the first day instead of 0th day. Fair enough. Okay, great. So let's move on. Try question number 3. It's an interesting one. Be watchful. Try that out. Take your time. The mistake you are expected to make is when you do not look at the 0th day concept and try to do the question. Learn the concept of 0th day, it becomes easier. 30 seconds more. Now, people had missed it by a whisker. Some of you had called it 2006. Some of you had called it 2008, and all of that was turning out to be a problem. 2007 happens to be the correct answer. Let's have a look at this. Which earliest year after 2001 will have the same calendar year as that of 2001? Please stop your solutions and listen to me. The zeroth day for us will be what? 31st December 2000. This will be my zeroth day, correct? From there, I'll try to look at it that if this zeroth day turns out to be same for an year ending, then the next year should have same starting. And if the next year, because this is non-leap year, if the next year happens to be a non-leap year, then I will call it as a same year. Clear? Now, look at 2001. How many odd days 2001 will have? How many odd days 2001 will have? Is this a non-leap year or a leap year? Rishika, that's incorrect. Be careful. 2001 alone is what I'm talking about. It's a leap year. It's a non-leap year, right? So non-leap year will have how many odd days? Just one. Clear? 2002 will have how many odd days? One. 2003 will have how many odd days? One. 2004 will have how many odd days? Two. If I go all the way up to 2004, I will realize it is talking about 5 odd days. So 2004 is not ending on the same day as that of my zeroth year, correct? Zeroth day. That means what? 2005 will not start the same as 2001, correct? So that is why I'm trying to bring a zero ultimately over here. So this is 1, 2, 3, 4, 5. 2005 will be what? 1. So that will make it what? That will make it 6. 2006 will make it one more. So till this, you will have 0 odd days. That means what? 2006 ending will be same as 2000 ending. That means 2007 starting will be same as 2001 starting. And this is a non-leap year, and this is also a non-leap year, and hence the earliest year which will have the same calendar will be 2007. Does this make sense? Any doubts, anyone? Let me know. Clear? Okay. Try question number 4. Take your time. Think about it. It's an interesting one, might take a little time. Okay, let's have a look at this, and I want all of you to stop your solutions and listen to me. It's a longer calculation, I do agree with this, but I just wanted to ensure that you get a flavor of how the questions can be made longer. I just want you to please pay attention on the screen, stop your solutions and listen to me. The earliest year after 2020, which will have 2048, is the correct answer. So please provide me with the recording. My mind has stopped working, been a long days. Fair enough. You will get this recording, no worries. Which earliest year after 2020 will have the same calendar year as 2020? Okay, so my zeroth day will become what? 31st of December 2019. With respect to this, I will try to calculate the odd number of days. Wherever the odd number of days becomes zero, I will have to look at the following year and understand, as this is the leap year, the following year should also be a leap year. And if that turns out to be a leap year, then it becomes easy for us to answer that question. Okay. Now I have built up this table. I know you might not be able to draw a very clear table during the exam. I understand all of this, but understand how to go about doing such a question. That's all. Please pay attention to this. 2020 is a leap year. We'll have how many odd days? Two odd days. 2021, 1, 2021, 23 will have 1, 24 will have 2. Why did I not stop at this 1 over here? Because I know this is not giving me 7 odd days. So 2 plus 2, 4 and 3, 7. This is giving me 0 odd days till this. So I know till 24 is not a problem. But 25 is a non-leap year. Correct? And what were we discussing? We were discussing a leap year, right? That is the problem. So that is why 2025 will not turn out to be the same year as 2020. So now 2025 will have one odd day, 26 will have one odd day, 27 will have one, 28 will have two, 29 will have one, 30 will also have one. So this will give me 0 odd days. But again, 31 is not a leap year. It is a non-leap year. Clear? So this will again give me one odd day. This will give me two odd days, one odd day, one odd day, one odd day. So if I look at this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Till this, I will get 0. But again, 2042 is not a leap year. So again, I'll start with 1, 2, 3, 4, 5, 6, 7, 0. 2048. Is it a leap year? Yes, it is a leap year. So the answer to this question should be option D, 2048. Any doubts, anyone? Any further? It was a long question. I do concede that fact. It was not easy to draw this table during the paper. I understand that. But I still feel it is a manageable question. It should not be a drop. Any doubts, anyone? Yeah. Sorry. If you clearly draw the table, you will be able to get down to the answers. No worries. Try fifth. Take your time. Rajni, total number of days from the first visit till the last visit. That's the answer that we are looking at. Total number of days from the first visit till the last visit is what we are trying to calculate. Guys, starting from the first day till the last day, total how many days are there in between is what we are looking at. Nikhil, please correct your answer. Okay, let's try and have a look at this. I will tell you the different variations possible on the answer, and I would want you to look at those variations when you are sitting back at home. Okay, all the variations will yield the same answer. I'm telling you upfront. I'll tell you what are the variations. Also, sit back at home and try and do this. I'm going to do one variation, and then the other three variations I'll leave for you to sit back and do. Okay, the first year. Guys, the answers are have been incorrect. There's nobody who has given me the correct answer. Now pay attention. Now, the first year can be a normal year, second year can be a normal year, third year can be a normal year. In that case, the next year has to be a leap year, followed by a non-leap year, a non-leap year, and a non-leap year, and so on and so forth. Correct? Now, we all know that a non-leap year will start on the same day and end on the same day. I repeat, the non-leap year will start on the same day and the last day will also be the same day. So I'm looking at the first day and I'm looking at the last day. I'm looking at the first day and I'm looking at the last day. Clear? That's what we are trying to look at. Okay. Now, the first day and the last day. Suppose the first day is Monday of this, then the last day will also be Monday. And it does not make sense to go on this Monday because I want to minimize the number of days he has taken to achieve this. Correct? So he will not go on the first day, but he will go on the last day, which is Monday. So the next year will be a Tuesday to start with, Tuesday to end with. He'll go on both the days. Then on the next normal year will be a Wednesday, will end with a Wednesday. Next is a leap year, which will start on a Thursday but will end on a Friday. Correct? Next normal year will start on a Saturday, or a non-leap year will start on a Saturday and end on a Saturday. Next year will start on a Sunday. With this Sunday, he will end. Why? Because he has gone to the pub on every single day of the week possible: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. All of that has happened, right? So look at this. This is 365. This is 365. This is 365 plus 1. This is also 365. Correct? So I can simply say 365 into 4 plus this 1 plus a 1 over here and plus a 1 over here. So can I then simply say that this total should give me the answer? So 5 fours are 20, 6 fours are 24, 26, 4 threes are 12, 13, 14 plus a 3. So 1463 then turns out to be the answer. Is that clear? Any doubts, anyone? Any doubts, anyone? Now comes the variation that I was talking about. And you might want to say, sir, why did you start with a normal year? Why can't I start with the year like a normal, then a leap year, and then a normal, and a leap year? Why is this variation not possible? This is also possible, but will yield you the same answer. Okay. Now you might want to say, sir, why not I start with a leap year, then a normal year, then a normal year, then a normal year, and then go on a leap year, and then on a normal year? Will I get a minimum number of days in this case? Check this out also. So these are the cases that I was talking about. Sit back at home and solve it, and you will be able to understand what am I talking about. Started solving like this, but I took full year, not just the last day included first day. I made a mistake in considering the whole year instead of the first day alone. Fair enough. Both of you have made the same mistakes. Let's move on quickly, finish question number 6. Straightforward questions, should not take much time now. I think this should have been answered very, very quickly. I don't know why is it taking so much time. 10:47, what is the angle between the clock hand and minute hand? Nikhil, that's not correct. Kaushik, Diksha, both of you have given me the correct answers. Okay, let me just do it for you for first one. Rajni, that's correct. 10:47. Understand at 10:00. What is the position of minute hand? Minute hand is exactly at 12 o'clock, right? That means 0 degrees. Now from 10 o'clock to 10:47, how much time is the minute hand moving? Minute hand is moving for 47 minutes, and in each minute it will move 6 degrees. So it will give you the position of the minute hand with respect to the origin, which I am considering at 12 o'clock. Okay. So 7 6 are 42, 6 4 are 24, plus 4 is 28. So 282 degrees is the place where my minute hand will be. What about my hour hand? Till 10 o'clock, it would have moved every hour 30 degrees. Correct? So 10 hours would imply what? 300 degrees. So at 10 o'clock, it is at 300 degrees. After that, it has still moved for 47 minutes with a speed of half a degree per minute. 47 degrees, 47 minutes with half a degree per minute. This is going to give me what? 23.5 degrees. Okay, so this is at 323.5 and this is at 282. 323.5 minus 282 should give me the answer, which is turning out to be 41.5. Any doubts, anyone? So the first angle between the two of them should be a 41.5. Now very quickly finish off 635. I don't think this will require more time. Quickly finish it off. Nikhil, that's not correct. Diksha, Rajni, our answers are correct. No, Rishika, why with respect to 10? It is after this 300 degrees, right? Till 10 o'clock, it was at 300 plus for 47.47 minutes more. With a minute hand, the problem is that after every 60 minutes, it will come back to the original position. But this will stay at 300 degrees plus 47 into 1 by 2. Does this make sense? Nikhil, that's not correct. Paritosh, correct. Gokul, is it a typing error or a calculation error? Check again. Okay. 635 is what we are talking about. Minute hand, what will happen? Minute hand would have moved for 35 minutes after 6 o'clock, correct? At 6 o'clock, the minute hand comes back to the original position. So 35 into 6 degrees per minute. So 6 5s are 30, 6 3s are 18, 210 is the degree at which 210 degrees is the value at which the minute hand is when it comes to 635. Where is the hour hand? For 6 hours, it would have moved 30 degrees. 6 into 30 will give you what? 180 degrees. And for 35 minutes more, it would have been moving at a speed of half a degree per minute. So this will become 17.5. So this will become a total of 197.5. The difference of 210 minus 197.5 is a 12.5. I hope all of us are clear. Any doubts, anyone on this? Clear? Okay. Try question number 7. I think this is a straightforward answer. All of you should answer this very, very clearly, very quickly, without even using your pen and paper. Rajni, Kaushik, both of you are correct. Between 6 and 7, it will be the sixth meeting that you are looking at. Okay. Now understand, between 1 and 2, where did we meet? We said 1 hour 60 by 11 minutes, correct? Between 2 and 3, where did we meet? 2 120 by 11, correct? Between 3 and 4, where did we meet? 3 180 by 11, correct? So now where will we meet between 6 and 7? It will be the sixth multiple, right? So 3 360 by 11 is what? Sorry, 6 360 by 11 should be the time where we will meet, right? So you can solve this further and you will be able to get down to the answer, 360 by 11 minutes. I hope all of us are clear. Nikhil, just check your answer. That doesn't seem right. Clear, everyone? Okay. Try 8. Take your time. Okay. So on this question, I had created a trap by giving 12 as the answer. I think quite a lot of you have fallen for that. Okay. Now please pay attention. First thing, it is set right at 3 p.m. has got no relevance. Whenever you set it right, after exact number of hours, it will come back and show you the same time. Okay. Now, clock is losing 5 minutes every hour, right? Now tell me first thing, how much should it lose? Right now, what is the question saying? It is losing 5 minutes every 1 hour. 1 hour of actual time, it will lose 5 minutes. So instead of reflecting 1 hour, it will only reflect 55 minutes. Clear? Now tell me something, that if it has to reflect the correct time again, how much should be the loss? How much should be the total loss? Kaushik, that's not correct. Paritosh, that's not correct. How much should be the total loss? Rajni, correct. Kaushik, correct. Nikhil, that's still not correct. How much should be the total loss for it to reflect the correct time? Rishika, that's not correct. Okay, let me deal with this answer which people have given me, which is 60 minutes. If there is a loss of 60 minutes, will it reflect the correct time? Imagine, if it is a loss of 60 minutes, that means it is an equivalent to 1 hour loss. That means if the clock is showing, suppose 7 o'clock, then the actual time would have been 8 o'clock. It will be just 1 hour gap, right? If you say 60 minutes of loss, ideally it should lose how much in order to reflect the correct time? If we are not able to visualize this, we will not be able to solve this question. It should be a loss of 12 hours. Now think about it. It should be a loss of 12 hours. That is when it will reflect the correct time. I'm still giving you 30 seconds to visualize this. Does it make sense? Just say yes on the chat box if it makes sense. I'm saying it should lose 12 hours. If it loses 12 hours, it will reflect the correct time. Several of you had given me several other answers. Does this make sense to you? Loss of 12 hours will reflect the correct time. So let's say if it is 3 o'clock. Okay, so let me now start giving you more detailed understanding. At 3 p.m., the actual time and the reflected time on the clock. Okay, so I'm just trying to look at this. 3 o'clock, it is 3 o'clock. Clear? Now, at 4 o'clock of the actual time, what will be the time reflected over here? It will be 3:55. Correct? At 5 o'clock, what will be the time reflected over here? It will be 4:50. At 6 o'clock, what will be the time reflected over here? It will be 5:45. This is how the clock will move. Does this make sense? So it's a loss of 5 minutes over here. Sorry, it's a loss of 5 minutes over here. It's a loss of total of 10 minutes over here. It's a total loss of 15 minutes over here. When will this reflect the correct time again? It will reflect the correct time again when this loss turns out to be of 12 hours. Does this make sense now? If it's a loss of 1 hour, it will not reflect the same time, isn't it? So 12 hours. Now understand this thing. So in order to lose 5 minutes, it requires how much time? It requires 1 hour of actual time. That means in 12, in order to lose 1 hour, it will require how many hours of actual time? It will require 12 hours of actual time in order to, so I'm multiplying this by a 12. If I multiply this by 12, it will give me what? 1 hour of loss. That happens in 12 hours of actual time. Correct? I need a total of 12 hours of loss. 12 hours of loss will mean what? 144 hours of actual time. After 144 hours of actual time, it will reflect the correct time again on the clock. Any doubts, anyone? It's a game of visualization. Clear? Okay. Now, those of you who were looking at the options in the PDF that was shared with you, it was my bad. I had given bad options over there. These are the options on the screen, and now try and do the question. Okay. Sir, can you please explain after 12 hours of loss? Now, understand, Paritosh, tell me something. Is this 12 hours of loss okay with you? That it should have a 12 hours of loss? Okay. Now understand, it loses 5 minutes for every 1 hour of actual time, correct? So if you multiply this equation by 12, it will become what? 60 minutes of loss in 12 hours of actual time, correct? 60 minutes is nothing but 1 hour. So 1 hour of actual loss, 1 hour of loss time will happen when? In 12 hours of actual time. So 12 hours of loss will happen in 144 hours of actual time. Is that clear? Okay. Try ninth. Do not look at the options given to you on the PDF. Look at the options given on the screen. After this, we have one last easy question. Try this out. Take your time. Question number 9. The ideal thing that I want from my students is that they should be able to get down to the exact time where this will happen, and then it will be a fun to look at the nearest, time on the clock. At best, a 30 seconds more. Any answers? Let me know. None. Okay. Now pay attention. Ravi leaves his house between 3 p.m. and 4 p.m. and returns between 4 p.m. and 5 p.m. Okay. People need a bit more time. So let me give you a minute more. Take your time. Okay. Let me now have a look at this question, guys. Please pay attention. The clock is between 3 and 4 p.m. that is given to you very clearly and returns between 4 p.m. and 5 p.m. And he observes that the position of hour hand and minute hand have interchanged. That's the only thing that he's observing. Okay. So now, if you look at your clock, between 3 and 4 is what they're talking about. This is 3 o'clock, this is your 4 o'clock, this is your 5 o'clock, and this is your 6 o'clock. It has to be in such a way that when he comes back between 4 to 5 p.m., so your hour hand definitely has to be between 3 and 4 initially to start with. So, but then your minute hand must be between 4 and 5 because the hour hand and minute hand have interchanged the position and the new time is between 4 and 5. That means your minute hand originally was between 4 and 5. Clear with this? And your hour hand was between 3 and 4. Now, I want you to, let's say this angle over here is theta. Okay. Now, can I then say that minute hand would have traveled a distance of 360 minus theta degrees, and the hour hand would have traveled a distance of theta degrees. Any problems, anyone? The minute hand will move from here and come back to this position, correct? That means the minute hand would have moved 360 minus theta degrees, and the hour hand would have moved how much? Theta degrees. Does this make sense? Any doubts, anyone? Okay. Can I say that the time period taken by both of them must be equal? The time period taken for both of them must be equal because it is happening in the same time period, right? The entire hour hand was also moving and the minute hand was also moving for the entire time period. What was the speed of the hour hand? Half a degree per minute, correct? And what is the speed of minute hand? 6 degrees per minute. So speed into the time should be equals to distance. Distance will be in degrees and time is the same for both of them. So can I figure out the distance by speed, which will be time for both of them? Distance was what? 360 minus theta degrees divided by 6. That should be what? The time period. And the time period over here should also be equal, which is theta by half a degree per minute. Correct? Any doubts, anyone? I've used this particular equation, which is time period is distance by speed. I'm trying to figure out for how much time was he outside the place, or the angle theta also, if that gives me, that should give me the answer as well. Okay, so let's just quickly solve this. 360 minus theta should be equals to 12 theta, and 360 should be equals to 13 theta, and this angle theta must be 360 by 13. Any doubts, anyone? This angle over here must be 360 by 13. Any doubts, anyone? Clear? Okay. Now tell me something. Now this is where it gets very, very interesting, and I want all of you to pay attention. How can you use something which is already known to you? This situation of the angle theta over here will happen after 3 180 by 11. Do you agree with this or not? Just say yes or no. This will happen after 3 180 by 11 only. What is 3 180 by 11? 3 180 by 11 is the time when both of these hour hand and minute hand were together between 3 and 4. Correct? 0 degrees. Absolutely correct, Kaushik. This was the timing when it was 0 degrees. And this is the timing where the angle is theta degrees. How much time it will take for them to create this angle is going to be added to 180 by 11, and that will give me the time on the clock, the original time on the clock. Does that make sense? So they have to now create an angle of 360 by 13 in between them at a pace of 5.5 degrees per minute, right? The angle that they need to create is 360 by 13 at a pace of 5.5. So how much time it will take? 360 divided by 13 divided by a 5.5. Clear? Or 5.5 is 11 by 2. So 360 by 13 divided by 11 by 2. So it will become 2 by 11, and 720 by 130. 11 threes are 33. Okay, so 143. So 180 by 11 plus 720 by 143 should give me the answer. This will be the time. 3 hours will definitely be there, and this addition will give me the timings that should be there on the clock. So it should be 180 into 13 plus 720 divided by 143. That should give me the value. Now this calculation has to be performed. We can perform that on the calculators and can understand as to how much is this value giving you. So if you do a 180 into a 13 plus of 722, which will be 3060 by 3060 by 143 is what you are getting. So if you divide it by 143, it is going to give you 21.39. So 3 hours 21.39 39 minutes is what you are looking at. So it is closer to 321. So it is closer to 321. Option A should be the correct answer. Any doubts, anyone? I know this was slightly tricky to comprehend, slightly tricky to get down to the answer, but that's the way to go about doing this. Any doubts? This calculation can be used 3 180 by 11, and from there it is going to take how much time to create an angle of 360 by 13 at a speed of 5.5. This should give you the timing 360 by 13 into 2 by 11, that is 720 by 143. Add that to 180 by 11 should give you the answer. It's okay if the answer is not in the perfect shape, but the content, the idea should be clear is what I'm talking about. Any doubts? Clear? Okay. Try one last question for the day. With that, we close. I'll read the question for you. The present time on the clock is 12 noon. The hour hand and minute hand of this clock are moving with the correct speed, but they are moving in the opposite direction. So either this can happen, what way? That means the hour hand is moving in the right direction, which is the clockwise direction, and the minute hand is moving in the opposite direction, which is the anti-clockwise direction. Or the minute hand is moving in the right direction, which is the clockwise direction, and the hour hand is moving in the anti-clockwise direction. These are the only two cases possible. I hope, Rajni, that clarifies the thing. Try this out now. Question number 10. Okay, I want all of you to pay attention to this. Let me do this on the screen and do it along with me. I'll keep asking you questions, try and answer to those questions. You will be able to get down to the answers. Now, please pay attention. I'm taking the case one. The case one I'm taking that the R hand is moving in the clockwise direction and the minute hand is moving in the anti-clockwise direction. Clear? Now, can you tell me in this particular case, in 24 hours, the clock will reflect the correct time how many times? Paritosh, I'm not getting that. In 24 hours, how many times will it reflect the correct time? Okay, tell me the first time in this particular case, case number one, first time when it will reflect the correct timing. Paritosh, that's the starting, right? So we will exclude that. What is the next time when minute hand is moving in the anti-clockwise direction? In 30 minutes, Muthu Kumaran, absolutely correct. Rajni, absolutely correct. Rishika, you are thinking about a wrong case. Our hand is moving in the clockwise direction, minute hand is moving in the anti-clockwise direction. So at what time will the clock show the correct time for the first time? At 12:30 it will show the correct time, isn't it? Because the minute hand will be at the correct position because it is running at the correct speed. And the hour hand is anyways at the correct position. So it will reflect the correct time, right? Can you tell me what is the next time after 12:30 where it will reflect the correct time? Rajni, Kaushik, Prakash, correct. At 1 o'clock, it will reflect the correct time, isn't it? At 1 o'clock, the minute hand will come back to the original position and the hour hand is naturally at the correct place. So in 1 hour, how many times is it reflecting the correct? Every 30 minutes it will show the correct time. Absolutely correct, Rajni. So every 30 minutes, if it has to show the correct time in 24 hours, how many times will it show the correct time? Absolutely correct. It will reflect 48 times the correct time. I hope we all are clear. And this is the maximum time that it can show you the correct timing. What is the difference between the maximum and the minimum number of times this clock can show the correct time in 24 hours? This is your case one. What is your case two? Case two is the hour hand is moving in the anti-clockwise direction and the minute hand is moving in the clockwise direction. That means, can you tell me which hand will always be at the correct place? I repeat my question. In case 2, which hand will be at the correct place always? Minute hand will be at the correct place always because it is moving in the clockwise direction. Now, can you tell me what is the first time after 12 o'clock that the clock will reflect the correct time? Prakash, that's not correct. Think again. Kaushik, correct. Paritosh, correct. When does the clock show the correct time? When both the handset are at the correct place, right? So only at 6 p.m. it will reflect the correct time, correct? Does this make sense? Now can you tell me the second time where it will show the correct time? At 12 midnight, it will show the correct time. Then at 6 a.m. again it will show the correct time. Correct? Then at 12 noon, it will show the correct time once again. That means from the 12 noon to another 12 noon, which is 24 hours, it has reflected 4 times the correct timing. That means in 48, in 24 hours, it has reflected how many times the correct time? 4 times. This is your minimum number of times it will show the correct time, and this is your maximum number of times that it can show the correct time. What is the difference between the two of them? 48 minus 4, that's going to be 44 as the answer of this question. Any doubts, anyone? Any part of it that you are not clear with? Done. Fair. Can you explain the part 2 again? Ajay, part 2 is our hand is moving anti-clockwise, minute hand is moving clockwise. Do you agree that minute hand will always be at the correct place in the second case? Yes or no? Okay. Now look at the hour hand. If the timing has to be correct, then what has to happen? Both hour hand and minute hand has to come at the correct position at the correct time. The first time after 12 noon that your hour hand will come at the correct time will be at 6 o'clock, isn't it? Because the minute hand will be at the correct time anyways. So if it comes back at the center point, that is the only time where it will be at the correct timing, right? Does that make sense? After 1 hour, the situation would look like this. This is your 12 o'clock. After 1 hour, the situation will be this, that hour hand will be over here and minute hand will be back to this place. Correct? After 2 hours, what will be the situation? The hour hand will come back to this place, but the minute hand will be over here. It will not reflect the correct time. When will it reflect the correct time? Only when the hour hand will come at 6 o'clock. Does this make sense? It is pure visualization. Our hand is always incorrect except at 6 o'clock and except at 12 o'clock. That's all. So 6 p.m., 12 midnight, 6 a.m. and 12 noon. These are the 4 times when it will come back to the correct position, and hence the clock will reflect the correct time. So the difference between the two of them will be 44. I hope all of us are clear. Right, then that brings me to the closure of the session. I didn't expect it to last for 2 hours, but I think it turned out to be slightly more tricky. But nonetheless, thank you so much, guys. Good night and take care. Thank you.